Okay. Alright guys, so this video is just about reviewing for that last test that you took. I gave you a pink copy like this. I'm going to actually try to take these and actually post them right next to this video so you can look at all the questions. My concern is I don't know if you're going to be able to see all the small numbers on there. So anyway, it is what it is. I'm going to go over some of those examples right now, everything you need to know for that test. Okay, so starting off, let's start with least common multiple and greatest common factor. And those are actually pretty difficult. This is the toughest thing on that test, all right? So if I'm taking like the least common multiple or greatest common, let's start with least common multiple of 60y and 56x squared. So I'm taking the least common multiple of 60y and 56x squared. So I need to start off by doing this prime factorization. So what I mean by that is just breaking 60 down using prime numbers. So I talked about this. The easiest prime numbers to use, 2 and 5 typically. So I'm going to divide this one by 2. If it's even, I always divide by 2. So 2 and 30. 30 is even, so I'm dividing by 2 again. 2 and 15. 15 is divisible by 5 and 3. So 3 times 5. And this is when you know you're done breaking a number down. You've got all prime numbers along this outside. So 2 times 2 times 3 times 5. That's the same thing as 60. So 2 times 2 times 3 times 5. So I'm going to write this out. 2 times 2 times 3 times 5, and then there's a y on the end, times y. Okay, so that's one of them. 56 is going to be, so 56 is even, so I'm going to divide by 2. And that'll be 28. 28 is even, so I'm going to divide by 2, and that's 14. 14 is even, so I'm going to divide by 2, and that's 7. So look, 2 times 2 times 2 times 7. Notice they're all prime numbers, and that's how I know that I'm done doing the prime factorization of this. So 2 times 2 times 2 times 7. 2 times 2 times 2 times 7 x times x. Okay, so I'm going to do both of these. I'm going to do an x times x is the x squared. So here's 56x squared. Here is 60y. I'm going to do a GCF first, and then I'm going to do the LCM. So if I want to find the GCF, remember, you're talking about common factors. You're looking for factors that they have in common. So when I look at both of these numbers broken completely down, I'm looking for common factors. So for example, I see they both have 2's. So they share that. They have that in common. How many 2's do they actually have in common is the question you have to answer. So here's 1. Here's 2. So for my GCF, I have 2 2's. That's what they have in common. This 2 is not going to be in there because this one doesn't have a 2. It doesn't share that 2. They don't have it in common. So I'm not going to use that 2. Do they both have 3's? No. Do they both have 5's? No. Do they both have 7's? No. Do they both have y's? No. Do they both have x's? No. So my GCF is simply 2 times 2, and that's all I've got. Just 4. That's my GCF. Okay? My LCM, my least common multiple, is taking all the parts minimally that it takes to create both of these numbers. So it's usually, I think the LCM is a lot easier. So let me start over with this. This is 2 times 2 and this is 2 times 2. Okay. So if I'm doing an LCM, I'm just looking for whichever one has the most of a single type of factor. So right here, they both have 2's, but this one has 3 2's. So this one minimally needs all 3 2's. Okay? To be created. So in my least common multiple, I need all 3 2's. 1, 2, 3. This one only needs 2. But because this one has 3, I'm going to need 3 2's in my LCM. When I see the number 3, okay, this one has a 3, so it needs a 3 to be created. So I need a 3. Okay, so if I see the number 5, even though this one doesn't have it, with my LCM, I need a 5. When I see a 7, even though this one doesn't have a 7, this one needs a 7 in order to be created. This one needs a y in order to be created. This one needs 2 x's in order to be created. Okay. Now, I don't think this was a great example for an LCM, so that's why I'm going to be working multiple examples. But anyway, when you get this, you want to multiply all this together. So 2 times 2 times 2, that's 8. This is going to be almost impossible to do in my head right here. But 8 times 3 is 24. 24 times 5, that's 120. And 120 times 7, that's 700, 840. 840, y, and then x times x is x squared. And that would be my answer for my LCM. Okay, let's do another example total. Total different example. And I hope I multiplied that out right. You can check it on your own calculator if you want. Okay, let's do these two. So 36xy cubed and 24y squared. So again, prime factorization. So I'm going to start off with 2 and 18, 2 and 9, and this is 3 and 3. So 2 times 2 times 3 times 3, x, y cubed, 1, y cubed. Okay, 24 is going to be 2 times 12, which is 2 times 6, which is 2 times 3. So 24 is 2 times 2 times 2 times 3, y squared. Okay, so here is 36 x y cubed, 24 y squared. So if I'm going to start off getting the, I'll write in a different color real quick. If I'm going to get the GCF, I'm looking for the least common factor, or greatest common factor. Okay, so common factors. I'm looking at 2's, they both have 2's. 1, 2, 1, 2. 2 2's, 2 2's. 3 2's? Nope, no 3 2's, so I'm not going to use that one. So in my greatest common factor, I can only use 2 2's. When I look at both, I see a common factor of 3, so I can use the 3 as well. 1 3, 1 3. I can't use the second 3 because this one doesn't have a second 3. So remember, you can only use factors that they both have. All right? This one has an x, that one doesn't, so I can't use an x. This one has 3 y's, that one has 2 y's. So I can use a y. How many y's can I use? 1, 2 y's. I can't use that y. Okay? So there's my greatest common factor. These are all the factors that they share. Both of these numbers share 2 2's, 1 3, and 2 y's. So 2 times 2 is 4, times 3 is 12. 12y squared. All right? So there's my greatest common factor. So the biggest number that can divide both 36xy cubed and 24y squared is going to be 12y squared. Okay, least common multiple. Now I'm just looking for the smallest number that both of these numbers will be able to divide. So you do that by just looking for the biggest amount of each factor. I always have a hard time saying this. I'm just going to try to say it as articulately as possible, but it's kind of difficult. You're looking for the greatest amount of a specific factor that each of these numbers possess. Okay, so for example, when I look at 2's, this one has 2 2's, this one has 3 2's, but I'm looking for the greatest number of that factor. So 3 2's. I'm going to use all 3 of them. When I think about 3's, I'm looking for the greatest number of 3's. So here's 1 3, here's 2 3's. So the greatest number of 3's is 2 3's. When I look at x's, this one doesn't have x's, this one does have an x. I'm looking for the greatest number of x's. So 1x. This one has 3 y's, that one has 2 y's. I'm looking for the greatest number of y's. So 1, 2, 3 y's. So now I've gone through every factor. This is my least common multiple. When I multiply this all out, that's going to be the smallest number that both of these numbers will be able to divide. Hey guys, can you look at that real quick? Is it still recording? Still blinking red? Perfect. 2 times 2 times 2 is 8, times 3 is 24, times 3 is 60, 72. So 72, x, y cubed. X, y cubed. So that's my least common multiple. You done? This is the other half too, right? There's 10 right here. There's another assignment on that same thing, the other 10. But hold on to that. Make sure they all get turned in together. Okay, I think I'm done with GCF. I don't want this video to be too long, so I'm going to stop on the GCF. Here's one for you to try on your own. Try 140n, 140m squared, and 80m squared. Try to take the GCF and the LCM of all 3 of these numbers. So break them all down. GCF, you're looking for the smallest number, or I guess the greatest number of common factors that they all have. The LCM, you're looking for the greatest number of each type of factor that they all have. Okay? All right, so moving on, and hopefully I don't want to spend too long on this, like I said. So I'm going to go into simplifying square roots. So simplifying square roots is a lot like what we just did. you want to start off by breaking these numbers down, doing that prime factorization. So that's even, so I'm going to divide by 2. That's 360. I'm going to divide by 2. That's going to be 180. Notice, as I divide and I put a prime number down, I always kind of keep them on the left side. So you'll see my factor tree is always kind of sloped to the right. That's easy to keep it organized that way. Divide by 2 and 90. Divide by 2 and 45. That's not divisible by 2, but it is divisible by 5, which is a different prime number. You just have to make sure you're dividing by prime numbers every single time. 9 is 3 times 3. So notice now when I'm done, I have all prime numbers. 2 times 2 times 2 times 2 times 5 times 3 times 3. What that is 720. So let's write this out. I have 4 2s, 2 3s, and a 5. 4 2s, 2 3s, and a 5. 4 2s, 2 3s, and a 5. Okay, so 720. Now, I taught you in 2 ways. I taught kind of the brainless way of doing it, just kind of going through the motions. You can pull out pairs of these. So 1 pair of 2s, 2 pairs of 2s, and a pair of 3s. So I have 2 pairs of 2s and 1 pair of 3s. What's still left under that square root is a 5. Okay, so my final answer is 2 times 2, which is 4, times 3 is 12. 12 square roots of 5 is my final answer. Now, here's the actual reason that we're pulling out pairs, though. Because we're talking about a square root. 2 times 2 creates a perfectly square number. 2 times 2 is 4. And the square root, if it's going to come out, if 2 times 2, which is 4, if 4 is going to come out of the square root, I need to take the square root of it. What's the square root of 4? It's 2. What's the square root of 4? It's 2. What's the square root of 3 times 3? 9. What's the square root of 9? It's 3. And then what's left under? Square root of 5. So that's that's the actual understanding behind what we're doing. So let me do one more example. Square root of 320. It's even, so I'm going to divide by 2. You can divide by 3, maybe. You can divide by 5. Actually, you can't divide by 3, but you can divide by 5. There's a lot of prime numbers that you actually can divide by. I like using 2 when I see an even number. So that's 160. Even number again, so I'm going to divide by 2, that's 80. Even number again, I'm going to divide by 2, that's 40. 2 is 20. 2 is 10. 2 and 5. And then all prime. 2, 2, 2, 2, 2, 2, 5. So I'm done with my prime factorization. I have 6 2s and a 5. So square root of 320 is the same thing as 6 2s. 1, 2, 3, 4, 5, 6. 6 2s. And a 5. So again, I'm pulling out perfectly square numbers. 2 times 2 is 4. Square root of 4 is 2. 2 times 2 is 4. Square root of 4 is 2. 2 times 2 is 4. Square root of 4 is 2. So notice I pulled all those 4s out of the square root and wrote them as 2s. What's left under the square root is a 5. So 2 times 2 times 2 is 8. Square roots of 5. Okay, again, I don't want to spend too much time on this, guys. Hopefully it's a review if you were paying attention earlier on in the year. All right, so I'm going to erase that. Also, here's another thing. If you still don't understand this, then get on YouTube, and this is how I learned a lot of stuff in college. If I wanted to learn how to simplify exponential expressions, I would type into YouTube, simplifying exponential expressions. If I wanted to learn how to simplify a square root, I would type into YouTube, simplifying a square root. If I wanted to learn how to find an LCM and a GCF, I would type into YouTube, finding LCM and GCF. Maybe if I wanted to find them with variables, I'd type in finding an LCM with variables into YouTube. There's videos on all this stuff. Okay, so I've done this. Now I'm going to do some simplifying exponents. So if I have 3a squared cubed, that's the same thing as 3a squared times 3a squared times 3a squared. 3 times, that's what that 3 is. So I'm going to write it out 3 times. 3a squared times 3a squared times 3a squared. That's what that 3 is. 3a squared times 3a squared, right? 3 times. Now when I start simplifying this, I'm just going to write it out as 3 times 3 times 3. Multiply the numbers together first, which is 27. A squared, that's 2a's, times a squared, that's 4a's, times a squared, that's 6a's, is a to the 6. Or you just end up adding the exponents together. Okay? I'm going to do another one now. So, if I have 2p cubed times 2p, and that whole thing is squared, that means I have this multiplied by itself. I need to multiply it 2 times. Okay, so 2p cubed times 2p. This, there's once, times itself, times 2p cubed times 2p. Okay, so multiply all the numbers together. 2 times 2 times 2 times 2 is 16. P cubed times p. So this is 3 of them. 3, 4, 5, 6, 7, 8. Okay, that's another just regular p. All right, so I have p to the 8th. Or remember, like I said in the last example, you just add the exponents together when you're multiplying things with exponents. All right? So there's an example of how to multiply exponents. Let me cross these off as I go through them. Okay. Here's more multiplying exponents without parentheses. So if I have something like this, it's the same idea. Multiply the numbers together. So I have 6 times 6 is 36. I have x squared times x cubed. Notice I don't multiply with the well, I mean it is multiplied with the y, but I'm only combining the x's. Okay, so x squared times x cubed is going to be x to the 5th, and then I have a y to the 4th. I'm going to put it right here. Okay, so that's the answer. It really is that simple. Are we still recording, guys? All right, cool. Next one. uv times 4uv to the 5th. Okay, so I'm multiplying the numbers together. I have 4 times, well, you can kind of just imagine a 1 being there. It's an imaginary 1, but most of the time people don't put that. So it's just 4 times 1, though, is 4. Okay, u times u is u squared. V times v to the 5th, so that's v to the 1st times v to the 5th is v to the 6th. Again, if you don't understand this, go ahead and type in like multiplying expressions with exponents in YouTube and watch some videos. All right, dividing expressions with exponents. 8x cubed divided by 10x to the 5th. All right, so when you're dividing, you're just, instead of adding the exponents like we were doing a second ago, now you're just going to be subtracting them. So you have, but a good way to actually see that is like this. If you write it all out. So if you're subtracting, think about it. 3 minus 5, you end up with negative 2. All right, but here's an easy way of doing it also. Just cancel things out. Okay? Because anything divided by itself is just 1. So you can just cancel things out. Notice you have 2 left on the bottom. So my final answer is going to have 2 x's left on the bottom, or x squared. Then 8 divided by 10 can be reduced. You can divide that by 2 and divide this by 2. So you end up with 4 on top, fifths. So 4 fifths is the 8 tenths. All the x's cancel out, leaving 2 x's on bottom. And that's why the answer is like that. And remember what I was talking about, negative exponents. So if I put this up top, I could put it like this. 4x to the negative 2 divided by 5. So remember, 3 minus 5 is negative 2, and that's why. Negative exponents, remember, you can put them on the opposite side of the fraction bar, and they become positive. All right? So there's one example. Here's another example. 14x to the 4th, y to the 7th, divided by 6, x to the 5th, y to the 4th. Okay, so 14 over 6, I'm going to reduce that first. That's going to be, I'm going to divide them both by 2, so 7 over 3. Okay, x to the 4th divided by x to the 5th. So think about it. You've got x to the 4th on top, 1, 2, 3, 4. X to the 5th on bottom, 1, 2, 3, 4, 5. So when you're canceling, 1, 2, 3, 4, 1, 2, 3, 4. You can cancel 4 out. You're going to be left with 1 on the bottom. Okay, so I have 1x left on bottom after these cancel out. Y to the 7th on top, y to the 4th on bottom. So imagine 7 y's on top, 4 y's on bottom. When you cancel them out, you're going to be left with 3 y's on top. If you don't understand what I'm saying, just literally write it out. 7 y's on top, 3 y's on, or 4 y's on bottom, and cancel them out, one by one. Okay, so that's my final answer, though. And again, if you don't understand that, then look it up on YouTube. There's videos all about this stuff everywhere. Okay. All right. Last one that I want to do has a negative exponent in there. Okay. So remember, negative exponents, to make them positive, you can put them on the opposite side of that fraction bar. So you have 12 over 9. I'm just going to rewrite the whole problem with positive exponents, though. And then this y to the negative 8. So notice, everything is stayed in the same spot, except this y to the negative 8 right here, I'm going to put on top with a positive exponent. Okay, now I'm going to simplify. 12 divided by 9 would simplify to, they're both divisible by 3, so 4 over 3. X, so that's this one. X cubed over x to the 5th. So imagine 3x's up top, 5x's on bottom, cancel them out. You're going to end up with 2x's still on bottom, or x squared. And then I have y to the 8th, nothing to cancel. So it's going to stay as y to the 8th on top. All right? And that'd be the answer. All right. So, again, remember, negative exponents go on the opposite side of the fraction sign. Okay, that's that. Now just ordering numbers. I'm not going to write ordering numbers. So we're on ordering numbers. If I'm going to order the numbers 5/12, 39%, 0.54, 4 over 25, 3.9%, and 0.2. If I'm going to order all of these numbers from, let's say, we're going to do greatest to least. So if I'm going to order them from the biggest to the smallest, first I want to convert them all to decimal so I can compare them easily. So I type 5/12 into my calculator. I don't remember exactly what this is. I think I'm just going to say it's like 0.4. I'm going to say this is about 0.41. That's just me totally guessing. Percents, to turn those into a decimal, remember the word percent means divide by 100. Per-cent. Like 100 years in a century, 100 cents in a dollar. Per-cent means divide by 100. So if you want to convert that to a decimal, do 39 divided by 100 in your calculator. Or just take this decimal and move it twice. Okay? So this is 0.39. This one, obviously it's already given to you, is 0.54. This one right here, 4 divided by 25, type it in the calculator, you get 0.16. 3.9%. So type in your calculator, 3.9 divided by 100, and you'll find, if I move the decimal place twice, your calculator will tell you 0.039. And then this one is 0.2. So now if I'm just ordering them from greatest to least, really, for the most part, you can just look at the number right after the decimal place. So this is 0.5, that's the biggest. Like 54 cents. Then 0.41 would be the next biggest. Okay. Then the next biggest would be 0.39. Then the next biggest is 0.2. Next biggest 0.1. 0.16. Next biggest 0.039. And if you really wanted to do it totally correct, I would take all of these things and write it the way it originally was. So for example, 0.54, that 0.41 was 5 over 12. The 0.39 was 39%. 39%. 0.2 was 0.2. 0.16 was 4 over 25. And 0.039 was 3.9%. Okay, write it all back in its original form. Alright guys, use this video to help you study for the test. Use YouTube. If you don't understand something, use YouTube. Okay? Also, you can come to tutoring. You know my tutoring times are Monday and Thursday from 4:30 to 5:30 every single week. Alright? Or ask me in class.